All right, in this video, we're going to do U-sub with a definite integral, meaning that I have limits of integration. So I'm going to need to plug in. All right, so the first thing that we're going to do is we are going to go ahead and use U-sub to integrate this. And as you can see, I already started thinking ahead by underlining the x squared and the dx. And that if I let u equal x cubed, du will equal 3x squared dx. I have this to trade, so 1/3 du will equal x squared dx. Okay, so this integral is going to turn into the integral of 1/3 e to the u du. Okay, now my suggestion for first semester calculus students is to leave the numbers off. Do not write 0 and 2. 0 and 2 had to do with x equals 0 and x equals 2. I'm now in the world of u's. Okay, so what we're going to do is we're going to integrate this, put it back in x's, and then evaluate 0 and 2. Okay, I will show you an alternate way that you could do it if you want, but this is my suggestion for first semester, first time doing substitution with limits. Okay, so let's go ahead and integrate this. So notice I left it what I call naked. I left it naked. So here I'm going to integrate this, and the integral of 1/3 e to the u is 1/3 e to the u. Okay, so now I'm going to return it back to x's. Okay, and then I'm going to plug in 0 and 2. So what you're going to notice is I get 1/3 e to the, let's see, 2 cubed is 8, minus 1/3 e to the 0 cubed is 0. And if we want, we could clean this up just a little bit. So this would be 1/3 e to the 8 minus 1/3. Heck, we could even factor out a 1/3 if you want, but that's our answer. Okay, so going over those steps again, leave the limits off, integrate it, switch back to x's, plug in our numbers, get our answer. Okay, so if you want to know where most students make a mistake, let me show you. So what happens is that people go through all of this, right? And they put a 0 and a 2 here, thinking that these numbers just come along. And then they integrate it, and then they put a 0 and a 2 here. And then they plug in 0 and 2. And what you're going to notice is that we got close to the final answer, but not exactly. You see how my screw up was a 2, but the actual answer is an 8? Wah, wah. Okay, that happened because those values belong to x, and x isn't just x. Well, x is x, but u isn't equal to x. U is equal to x cubed. Okay, so what you may see in some solutions, if you just kind of go rogue on the internet, is that what they do is a lot of mathematicians don't like this idea of leaving it naked. So what they do is they basically say, okay, if u equals x cubed, then if x is 0, what would u equal? Well, if x is 0, u equals x cubed, so u would equal 0 cubed, so u would just be 0. Okay, well, what happens if x equals 2? Well, again, u equals x cubed, u would equal 2 cubed, so u would equal 8. So you may see in some solutions where they switch from x's to u's and switch the limits of integration. This does work. This may actually appeal to some of you, okay? What happens in this case, if you want to do this, is that then you can just plug in and we'll get the same answer that we got the right way. Okay. So you might be thinking, Jen, oh, I'm kind of confused now. What's the best path? My first part of the video. So for a first semester calculus class, typically what's best is to leave this off, integrate it, switch back to x's, and then just plug in the regular numbers. Okay? So that's why I started off with that method, because I think it's the simplest and most straightforward for your first time out doing these types of problems. All right, you might have to watch this video a couple times, but good luck with limits of integration along with U-sub.